Hi everybody, welcome back to Happy Little Diodes, where today we've finally got a toast rack to play with. Released in 1985, this was the first 128K Spectrum to hit the shelves. It seems to be everybody's favourite these days, I think because it looks cool, it plays 128K games, and it doesn't have a bulky cassette deck or floppy disk drive attached. So far on this channel we've seen countless 48K rubber key speckies, 48K Spectrum Plus machines, and Spectrum Plus 2s, so it's very exciting to finally have a toast rack to look at. If you haven't guessed, the nickname toast rack comes from the heatsink on the right hand side of the case. I did consider sticking a slice of toast in this toast rack just for a joke, but I think I'd end up with an angry mob after me. Let's have a look inside and see what we've got. As with a 48K Spectrum Plus, we need to remove these two ribbon cables to get the top half of the case free. Here's our voltage regulator, attached by an extension cable to the heatsink. This toast rack heatsink replaces the old heatsink that we've seen inside the 48K models. And I will be replacing this regulator with one that can deliver 2 amps. Toast racks also sometimes come with this very stylish toroid. The toroid forms part of the circuit which delivers the 9V input to our regulator, and it serves to remove noise on the 9V supply. Here we have from left to right our multiplexer chip, the Z80 CPU, and our ROM chip. These 3 chips in this arrangement should be familiar to you if you've ever dismantled an issue 6A 48K Speccy. And here's our 128K of memory spread over 16 4164 RAM chips. The 128K ROM employs a paging system to allow it to address so many memory chips. And in this corner, our Amstrad ULA chip, as well as other video circuitry, input and output, and our RF modulator. But we're not interested in the modulator because we now have an RGB port. And this is going to give us a really great picture compared to the RF output. We have the usual edge connector, and another big advantage of the toast rack, the power jack is the same as the previous 48K models, so you don't need a special PSU to provide all the voltages. I've got really lucky with this machine, and the keyboard supports here are still intact, so I'm going to safely put them away in a drawer so I don't lose them and I don't break or melt them while I'm working on it. Right, let's get the board out of the case, and to do that we need to disconnect the voltage regulator, and it's not soldered on or anything, we can just take off this connector. The reset switch just pops out of the case and we can leave it attached to the board. We just need to be careful working around it, and out it comes. And as is tradition, let's go straight in and recap the board first. I'm not going to try and keep the original colours of the caps, I think I'll just go for all blue. Before we get into it, let's flip the board over and check nothing's out of place. We can see that the multiplexer chip's been socketed, but that's okay. Here we can see it is a 6U board, which is more common than the 6K, and it was built in 1985, which was a good year for Megadeth. Sorry, got a bit distracted there. Anyway, here's the shopping list. 3 100 microfarad 16V capacitors, 3 47 microfarad 16V capacitors, 1 4.7 microfarad capacitor, minimum 5 volts, 4 22 microfarad caps, I'd go for 25 volts on these, and 3 1 microfarad caps of 50 volts. Full lists of capacitors are on spectrumforeveryone.com, and you might notice that where you have a few caps of the same rating, they actually have different voltage ratings, and that's why I've chosen the largest voltage rating just for all of the caps of the same value to make it more simple when ordering the parts. Okay, I've removed the heatsink so I can easily plug it in and test the board in between each capacitor replacement. And as you can see, the machine is working from the start, so if it stops working then I know it's my fault. Try to do them one at a time, or if you're feeling brave, I'm going to do them in 2s or 3s, starting with these 2 yellow ones. Just snip one side of the cap and bend up the cap, and that will allow you to remove it quite easily. Here's my preferred method, to carefully place the board in a vise, then you can heat the joint from the back while pulling from the front. Just be careful if it's being stubborn, bear in mind that the capacitor might heat up. and use some needle nose pliers, or if you're lazy like me, just use your snips to grab the remaining leg, heat the back and pull it out. We now need to clear the joint of solder. You can use solder wick or you can use the solder vacuum on the desk, but I like to keep it in the vise, which allows me to heat the board from the top, use the solder sucker on the bottom and save myself that tricky transfer where you have to quickly get the solder sucker over the joint before it freezes again. At this point, just check the capacitor that you've removed, check its rating. There's a chance the schematic might be wrong, or you might be reading it wrong. You might even have the wrong schematic open, so yeah, always just take a quick check of what's in front of you. We'll pop in the new capacitor and bend the leg sideways to hold it in place. And now the fun bit, we can do some soldering. Make sure you have a fine tip like this one and keep it clean. Be mindful of the temperature of your iron if you have a adjustable temperature iron, and try not to heat the joint for any longer than is necessary. This is a good example that my iron wasn't quite hot enough and it took a while for me to make a decent joint. And because I wasn't too happy with it, I've turned the temperature up and just reapplied some heat to make sure I have a good joint. And as you'll see here, I really didn't need to apply heat for very long to make a good joint on this one. The next stage is to trim these legs, being careful not to cut any traces by getting too close to the board. And at this point, just inspect the area you've been working on, look for any solder splashes, any bad joints, any shorts or breaks, and when you're happy, plug it in, see that it still works, and carry on to change the next few caps. Take your time, listen to something relaxing like Megadeth, and if you do find yourself getting impatient, just take a break. And while we're on the topic of soldering and iron temperatures, take a look at this joint in the middle that I'm about to heat. This thing is surrounded by solder, it's all underneath that solder mask, and as such, all the heat I'm applying is going to be dissipated around there, which means I do need to apply heat for longer than I would do for one of the smaller joints in order to make a good joint. There's a danger here that you'll end up with a cold joint, which would be no good. And I know I already said it, but you really do need to check for solder splashes, even if you just replace one capacitor. Here's a good example. This isn't actually causing a short, but something like this could very easily cause a short. And it's really easy to clean up. Just take some solder wick and apply a little bit of heat just for 1 second or so, rub it around and it's gone. Right, here's our fully recapped board, looking nice. But before we sew it back up, I do want to have a look at this voltage regulator. I don't strictly need to replace this regulator as the machine is actually working, but I want to show you what the current draw is of the machine on its own with no expansions plugged in. I've just checked the current limit on my power supply and let's plug it in and we can see 0.92 amps. That's quite close to the 1 amp rating of the regulator and makes me worry about expansions and extra things plugged into the edge connector, so I've ordered a replacement which can deliver 2 amps. And while we wait for that to arrive, let's clean up our keyboard. I have been asked before about how to remove the keys from these machines, so as you can see, all you need to do is grab the key from the sides, pull up and it pops off. So do that for all of the keys on the machine. Here's an important tip, leave the spacebar until last because this is tricky. It doesn't just pull off, so don't try pulling harder, you need to pull smarter. There's a metal hook which is holding it in place. As you'll see once I remove this, there are some fairly thin parts of the spacebar which may break if you apply too much force. So stick all those keys in warm soapy water and give the keyboard here a good cleaning out. And while all those keys are in the bath, here's our new regulator. I've gone for a Traco TSR2 2450 which can deliver 2 amps and runs cool, so we don't need a heatsink. Let's start by removing the patch cable which connects our board to the old 7805 regulator. I'll make a quick continuity check against the circuit diagram so I know I'm putting the new regulator in the right way round. and solder the new one in. Before I put it back in the case, I'm just going to clean up the bottom half of the case. I'm just using a microfiber cloth and some alcoholic spirit. And here's a problem. The Traco regulator is too bulky, it clashes with the heatsink. This makes it impossible to get the screws in to attach the PCB to the lower half of the case. I did manage to make it work by extending the legs and bending it back and extending the capacitor behind the regulator, but let's face it, that looks ugly, so I'm going to remove it. Instead, I put that patch cable back in and fitted a 7/8 SO5, which is a regulator which will generate heat but is capable of delivering 2 amps of current. This way the arrangement is as intended and the heatsink will get warm, but that's okay. And here we have our fully recapped and cleaned up Sinclair ZX Spectrum Plus 128K toast rack. I felt quite lucky getting this one working out of the box with all of the keyboard mounts and keys still fitted. It was a nice straightforward recap. Apart from the snag with the voltage regulator, everything seemed to go well, but as I found when I was testing, this machine actually can't load any 128K games. It does load 48K games, but there is an issue there which we're going to have to look into. So check back for part 2, where hopefully I'll have got to the bottom of this weird temperamental issue with loading games. Thank you for watching, wishing you all a very happy new year.